Beautiful. Okay, we're going to do transforming logarithmic functions, okay? So, here's our function. And what's important to realize is our log is to the subscript 10. So a lot of times when a logarithmic function is written, if you have y is equal to log of some number, or let's say x, if nothing's written in there, it's the assumption that we're of subscript 10, which means that would be the inverse of y equals 10 to the power of x. Okay? So just like if you're writing a root function, it's assumed that there is a number 2 in front of the root. It's assumed if nothing's there that it is to the power of, to the subscript 10. Okay, so our transforming of the function here, these letters, or hopefully you've seen them before, they are pretty much identical to whatever else you've used or whatever other function you guys have transformed. So in a value, it has to do with vertical flips, stretches, and compressions. Okay? If our a value is positive, okay, let's try to think about this idea. Or actually, let's say, how do we know if our a value is a stretch? What are the parameters of a, if it's a vertical stretch? You're looking at greater than 1. That's it. And you could write it the other way. And what if it is a vertical compression? Okay. Less than 1, greater than 0. And we're actually talking about the absolute value of a when we talk about that. Right? Because if we have negative 2, okay, it doesn't actually fall in there if we don't use the absolute value. So negative 2 would still be a vertical stretch. Okay? And how do we make it a flip on the, actually let's talk about what axis would it be flipped on if a is negative. If a is some negative number, what axis do we flip our function on? Yeah, on the x-axis. Good. On the x-axis. Excellent. Now, what about for our k value? Our k value deals with horizontal. Flips, stretches, and compressions. If the absolute value of k is less than 1, what is it dealing with? A stretch or a compression? Or sorry, greater than 1. Stretch or a compression? Are we unsure? Okay. What about the absolute value of k? Oops. Less than 1 and greater than 0. That's right. This is a stretch. This is a compression. Where with our vertical stuff, this is a stretch and this is a compression. Okay? So just keep that in mind. You're talking about horizontal stretch. So imagine you have an elastic band. If we're talking about a horizontal stretch, it would be taking that elastic band and pulling it left and right. Okay? A vertical stretch would be taking an elastic band and pulling it up and down. And then obviously a compression is the opposite of those two movements. Okay? And then finally, if our k value is negative, what axis are we flipping it on? The y-axis. Good. All right, let's talk about a vertical shift. Our c value. If our c value is greater than 0, which direction does this shift? Anyone know? Up, yeah. Which means if the c value is less than 0, it goes down. Good. Well, what about the d value? If d is greater than 0, which direction? So if it is a positive number, yes, we're going to go in a negative direction to the left, which means vice versa. Whoops, that's not vice versa. If d is less than 0, okay, we're going to the right. Okay, I know I didn't write many words there. We just use little symbols to help us remember these things. All right, so with that being said, let's see if we can actually play around with this function. So right now I have a logarithmic function, okay? If you notice there's no subscript, so that means it's subscript 10 in this case. So as I move our a value upwards, okay, you'll notice this is a vertical stretch. As that value is getting larger, it was pulling it farther and farther up. And then as it starts to come down again, it's a vertical compression, and then same thing again. So as our negative values grow farther and farther away from the number 1, it's again a vertical stretch. It's only in that very small range of, let's see if I can get it. Ooh, I'm good. Between 1 and 0 that we're getting a vertical compression. Okay, let's change this back to 1. If nothing is written there, it's assumed that a is the value of 1. Okay, with that same idea, our k value. As our k value goes up, what's going to happen? Horizontal compression. Okay, now it's hard to see, but as this line here is moving down, no, I don't want that to happen. Hold on, go back again. And slow it down. Oops. Okay, it's going to go back. Okay. This is a horizontal compression. Once it gets in the middle, this is where I want to talk. So imagine this thing is being squished from above. Okay, something's coming down, squishing it from above, or sorry, not above, from the right. Okay, and then from here, something's squishing it to the left. Okay, that is a horizontal compression, and then it's within that very small range. Oh, okay, I kind of got it. This is where we have a horizontal stretch, and if you guys really want to see this range, let's actually change the parameters to just be between 1. Okay, so this is everything here is a horizontal stretch. Still very hard to see. Okay, and maybe it would be better if we were showing the horizontal stretch of a exponential function too. So maybe we'll do that again with k, because I know k is hard to deal with. C value, as it goes up, function goes up. Not much happening to it. It's the exact same shape. It's just heading upwards. And as the values come down, the function just heads downwards. Okay, so as that d value gets lower, it just heads lower. So c and d, bring it back up here. Relatively easy numbers to work with. It's assumed that if nothing's there, the c value, as that d value, though it looks like it's a positive here, right? 6.7. If I was to write it into this function, a positive 6.7, it would show up as a negative value. Okay, can I change the color? Let's see. Should be able to do that. There we go. There we go. Okay, so you notice the exact same thing. If I were to actually have written it as log x plus 6.7, that's a very different number. So even though here it looks like it's a positive value, when it would be written into the function, it's technically negative. Okay, so it looks or it appears to be negative. Truly, the number is positive. Okay, and that's why it's actually shifting to the right. But because the function is written with a negative value in front of it, or a subtraction sign, it appears to be a negative value. And it's the same idea as it moves back to the left. You'll notice when we see if we can get to 6.7 again. Yeah, oh, just missed it. Negative 6.7, okay, is the same as when it's x plus 6.7. Okay, and the reason being, if we put a negative or we subtract a negative value, it's the same as a positive number. Okay?